Next classification method we are going to discuss is about Bayesian classification. It is having a statistical background. They can predict class membership probabilities such as the probability that a given tuple belongs to a particular class. It is based on a mathematical theorem known as Bayes' theorem. A simple Bayesian classifier is also known as naive Bayesian classifier, which is comparable in performance with a decision tree as well as some neural network classifiers. These have also exhibited high accuracy and speed when applied to large databases. Here we will see what is the meaning of naive. It is made to simply the computations involved, and in this sense it is considered naive. We have an assumption called class conditional independence. Bayesian belief networks are graphical models which, unlike naive Bayesian classifiers, allow the representation of dependencies among subsets of attributes. This can also be used for classification. So we are going to discuss about naive Bayesian classifier. Let's see what is a Bayes' theorem. In Bayes' theorem, we have to find some probabilities, and we have some hypothesis that is represented as H. Let X be a data tuple. Here in Bayesian terms, the X is considered evidence. As usual, it is described by measurements made on a set of n attributes. And let H be some hypothesis such that the data tuple X belongs to a specified class C. So that is an example for a hypothesis. For classification problems, we want to determine P of H condition on X. This is known as the posterior probability or posteriori probability of H conditioned on X. So be familiar with this. We have to calculate P of H conditioned on X. That is known as the posterior probability or posteriori probability of H conditioned on X. We will see all these by example. Let's define the terms first, then we will discuss it in detail by using an example. In contrast, we have to calculate the pH, that is the probability of this hypothesis. It is the prior probability or priori probability of H. Next one we have to see that the probability of H, which is known as prior probability or priori probability of H. Similarly, we have to calculate the probability of X conditioned on H, which is known as the posterior probability of X conditioned on H. Okay, the reverse process that we have already discussed. We have to calculate the probability of this particular data tuple conditioned on this hypothesis. That is known as the posterior probability of X conditioned on X. Similarly, we have to see the probability of X, that is the prior probability of X. So we have to see the prior probability of X as well as the H, that is the hypothesis, and we have to find the probability of H conditioned on X and the probability of X conditioned on H. So these are the terms we have to be familiar with. Now we are moving on to the Bayes' theorem, and the theorem says the probability of H conditioned on X is equal to probability of X conditioned on H into probability of H divided by probability of X. So this is the equation for calculating the Bayes' theorem. So these are the probabilities we have to estimate. So let's see this by an example. Here the naive Bayesian classification is an algorithm which include different steps, and we are doing it by using this Bayes theorem. Here the hypothesis is replaced by the class, that is we have class 1, class 2 or class 3, that is generally represented as Ci, and the x belongs to the attribute vector. So we are replacing the Bayes theorem by this equation, that is probability of Ci conditioned on x, that is equal to probability of x conditioned on Ci into probability of Ci divided by probability of x. So this is the equation we have to see while we consider it is for doing the classification. Next, we have to calculate the probability of x conditioned on Ci, and we will see this by an example. The same example we are considering here. Here x is a tuple with age equal to youth, income equal to medium, student equal to yes, and credit rating equal to fair. We want to classify this particular tuple, and we have to decide whether it belongs to the Bayes computer yes class or whether it belongs to Bayes computer no class. So we have to decide whether it comes with yes and or whether it comes to no. So this is a new tuple. We have to classify this using this Bayesian classification. We need to maximize the probability of x conditioned on Ci into probability of Ci for I equal to 1, 2. Here we have two classes, therefore I equal to 1 and 2. The probability of Ci, that is the prior probability of each class, can be computed based on the training tuples. We have a training tuple and this is the same example we have considered with the decision tree. You can see that table for reference. Okay, here we are calculating the probability of Bayes computer yes. Here we have 9 tuples among the 14 tuples comes in this particular class. So the probability is 9 by 14. We have a value like 0.643, and probability of Bayes computer no, we have 5 tuples in the no class category. So 5 divided by 40, that is equal to 0.357. To compute the probability of x conditioned on Ci for I equal to 1, 2, we compute the following conditional probabilities. We have to find the probabilities by using the equation that is probability of age equal to youth. That is the conditional probability. Here we are considering age attribute. When age equal to youth, then Bayes computer yes, that is the probability of having only 2 tuples we have in this particular youth category. So 2 divided by 9, that is equal to 0.222, and we are not mentioning the values here. It can be calculated easily, and the probability of age equal to youth Bayes computer no comes with 3 tuples, so 3 by 5. Like that we can find all the possible combinations, like probability of income medium, then Bayes computer yes 4 by 9, probability of income equal to medium, and Bayes computer no. We are considering both cases, that is the both classes we are considering here. Here we have 2 types of classes, that are yes category and no category. So we are checking with all this, and finally we get all these values. Then using the above probabilities we obtain probability of x conditioned on Bayes computer yes. Here we have the probability of age equal to youth Bayes computer yes into, and based on this given tuple we have to calculate this probability of income equal to medium bias computer yes into then probability of student yes then bias computer yes, and we are calculating the value and we get a value known as 0.44 here. Similarly, we have to consider this for the other class, that is the bias computer no case. Here we get a value 0.019. To find the class Ci that maximizes probability of x conditioned on Ci into probability of Ci, we compute the values, that is probability of x bias computer yes into probability of bias computer yes. Okay, so we get a value known as 0.028, and the next case also we are calculating, that is for the next class we are calculating probability of x by conditioned on bias computer no and probability of bias computer no. So we get a value that is 0.007. Therefore, the Ney-Bayesian classifier predicts the new tuple comes in category 1, that is the class yes category for tuple x. So this is the way the Ney-Bayesian classifier works. So I hope you understand what you mean by the probability of the hypothesis as well as the probability of the particular attribute, which are known as the prior probability, and we have to find the probability of the attribute conditioned on the particular hypothesis, as well as we have to find out the probability of hypothesis conditioned on this particular attribute, which are known as posterior probability, and these are calculated like this, and these equations can be used for doing the classification of a new tuple. So I hope you understand the concept very well. If you have any doubt, you can ask me.